What? They were all watching football at your house. Homework. I know you said something, but I don't remember what you said. 29 through 32. Oh, yeah, 29. 4x to the negative 2 minus 8x plus 1, and so all I have to do is find dy dx. Negative 8x, still back one off of that exponent, minus 8. Is that not your 29? So negative 2 times 4, negative 8, and then minus 1 on the exponent. 30? Yep. That's it. Yeah. Did y'all make it harder than it was? Yes. Yeah. I think that's why the other one. Yeah, keep it negative. That's fine. So it's, remember that rule I can do if I'm doing the derivative of 4x to the negative 2. I can bring that 4 outside. So 4 times the derivative of x to the negative 2. So then it's negative 2 in front, and then subtract 1 from the exponent. Let me mute my... $30 x negative 4 over 4. I think it's the negative exponents that are throwing y'all. Just for the sake of, so that you guys understand, I am going to change this to 1/4 x to the negative 4 minus 1/3 x to, I think it'll be a little easier for you to see. But in derivatives, the negative exponents are absolutely okay. Now I'm going to multiply, so multiply and back 1 off. So I get negative 1, right, because of 4 times 4, x to the negative 5. Multiply, so it's already minus, and now it's negative, so it's going to be plus x to the negative 4. Multiply, it's going to be negative, half times 2 is 1, x to the negative 3. Multiply around, it's already minus, so it's going to be plus x to the negative 2, and the derivative of a constant is 0. Does that make sense? Easy? I hope it's easy. Which other one? 31? 31's nasty. I am going to change all the square roots to an exponent of 1/2. And whenever I finish with the problem, I'll go back and replace my 1/2 with square roots. But for the time being, while I'm working with derivatives, I'm going to change it to 1/2. All right, so remember, to do this, I do the derivative of the top times the bottom minus top times derivative of the bottom all over the bottom squared. So I get derivative of the top. I'm going to bring it around, so that would be 1/2 x, and then subtract 1. 1/2 minus 1 is negative 1/2. That's the derivative of the top times the bottom minus the top times derivative of the bottom. 1/2 x to the negative 1/2. All over the bottom square. I do need to work with the top a little bit because it's not completely factored, just to make sure nothing cancels or simplifies. Yeah. You sure? I do it a little. All right, so if I distribute here, what does that give me? I know it's 1/2, but 1/2 times what? What is x to the negative 1/2 times x to the positive 1/2? What do you do when you multiply with the same base? You add them together. So it's 0, right? So it's x to the 0, which is just 1. Are y'all following me there? So when you multiply with the same base, you add the exponents, the x, right? So if I had x to the second times x to the third, it would be x to the fifth. If the bases are the same, I add the exponents. And so negative 1/2 plus 1/2 is 0. I'll keep it written in there for just a minute so that you can see. And then times 1, I have 1/2 x to the negative 1/2. Minus, and I'm kind of going to have to go backwards here to distribute. Again, this is the same kind of thing. So it's 1/2, that x is going to have a 0 on it, right? Minus 1/2 x to the negative 1/2. All over the bottom. All right, so this is really like this. So my 1/2s cancel. Now I've got 1/2 x to the negative 1/2 plus 1/2 x to the negative 1/2. Those look like terms to me. Do you agree? What is 1/2 x to the negative 1/2 plus 1/2 x to the negative 1/2? X to the negative 1/2, because a half and a half is a whole. And now I've got this single value up top, but it's got a negative exponent. I'm just going to chunk it down in the bottom, multiply it. So I get 1 over x to the 1/2 times x to the 1/2 plus 1 squared. If I choose to, I could change these 1/2s back to square roots. Generally, we would, since that's the way that the problem started initially, but it's not absolutely necessary. Either or is fine. And you said 32? Y'all okay here? Y'all sure? Positive? All right, 32. Don't y'all think these are fun? Could you imagine having to do these with the difference quotient? It would be horrible, wouldn't it? 32. 2 square root of x minus 1 over square root of x. I'm going to go ahead and change some things up that are going to make things a little bit easier for me as I derive. I'm going to change this to an exponent of 1/2. And I'm actually going to change this to an exponent of negative 1/2. Right, because it's in the bottom, it's a square root, that's a 1/2 exponent. So I'm just going to, that'll make my power rule even easier. Now for the derivative, multiply and subtract. Multiply, so this is going to become positive 1/2 x to the, remember I have to subtract 1, right? So it's negative 3/2. I don't see any need to combine these for any reason. If you just want to make them back into radicals, you could. 1 over the square root of x plus 1 over 2 times the square root of x cubed. But I mean, it's not necessary at all. What do y'all think? First day of derivative rules, shortcuts. Everybody okay? Ew, 22. Golly. I was gonna say, if I was doing this problem, if I saw it this way, instead of doing double product rule, top and bottom, I would probably multiply these out. Because polynomials are super easy to take derivatives of. They just are. So I would probably say, well, before I do this, I'm going to do x squared, 2x and 1x is 3x plus 2 over x squared, negative 2x and negative x is negative 3x plus 2. I think I'm going to be a little bit easier to derive there than before. So I'm going to do a derivative of the top, 2x plus 3, times the bottom, x squared minus 3x plus 2, minus the top times the derivative of the bottom, all over go okay there. And I would even leave the bottom as this squared, so that would be like x minus 1 squared, x minus 2 squared. I don't know how they do the answer in your book. I don't think this one even has the answer. Oh no, they left it like that. But either way, it doesn't matter. Start multiplying out, I suppose. Ugh. 2x cubed minus 6x squared plus 3x squared minus 9x plus 6. Did I miss one? I missed one. I missed 4x. 4x plus 3x squared minus 9x plus 6 minus, and I'm going to do this in parentheses so don't forget that this is all subtracted. 2x cubed plus 6x squared minus 9x plus 4x. Oh, I'm losing myself in it. Minus 3x squared minus 9x. What am I doing? Let me take the 2 to everybody. This should be plus 4. Now I'm going to take the negative 3. Minus 3x squared minus 9x minus 6. Oh, this looks nice. 2x cubed and 2x cubed cancel. Negative 6x squared. This is going to be another negative here. So that's negative 12. Negative 12 plus 3 plus 3. So negative 6x squared. Nines cancel. The 4's cancel. 6 and 6 is 12. Take out a 6, a negative 6. I think that's all you could do. Leave it like that because really it doesn't do anything. I'll probably stop right there. Does that make sense? Sorry, I wasn't even watching y'all to see if you were getting it. I was just engrossed in my problem. Y'all good? Yeah. Is it about this one? What you got? Okay, so, 2x or 2x cubed? Where'd you get that? You probably multiplied them like this. Right here. All right, 2x cubed minus 6x squared plus 4x. Did you multiply the 2 and the 2 together? There's so many places to make such a little error that ends up impacting your whole final answer. It stinks, yeah. Yes, but then I had a positive 3x and a positive 3x squared. I just kind of did them all at one time. Anything else on that one? Lots and lots of room. That's what's bad about those kind of problems. Hope, what did you have? 19? Golly, these are x minus 1 times x squared. Did y'all multiply this one out too? Yeah. Yes. You can. Okay, so if you do that, so remember the quotient rule is derivative of the top times the bottom minus the top times derivative of the bottom over the bottom squared. If I do that here, like if I don't multiply it out, whenever I find this derivative, this would be the product rule, and that's the only time you would use it. So it'd be the product rule times x cubed. You see what I'm saying? I'll do it that way so you see the different way to do it. You could FOIL it out, multiply it out, and have a big polynomial at the top, and do it the same way we did over here. Or I think that it's a little easier, but it's not wrong the other way. Some people like the other way. It doesn't matter. I'll show you the other way. That way you know. So if I do product rule up top, because I'm derivative of the top, right? So product rule says take the derivative of the first. What's the derivative of x minus 1? 1 times the second plus the first times the derivative of the second. And all of that, that's just my top derivative. So now I have to multiply that by the bottom. Does that make sense? And so it's derivative of the top, and so all of this is the derivative of just the top. But it's derivative of the top times the bottom. Now I have to do minus, because I still have to do quotient rule because it's still a quotient, right? So now I have to do minus, and I'm going to move these around. I'm going to do derivative of the bottom first. 3x squared times x minus 1, x squared plus x plus 1, and everybody goes over the bottom. That makes sense? Still lots of places to mess up. If I start cleaning it up a little bit, I have x squared plus x plus 1 plus 2x squared plus x minus 2x is minus x minus 1. And I still have this x cubed that sits on the outside. Minus 3x squared times x cubed plus x squared plus x minus x squared minus x minus 1. And I'm probably going to clean these up before I start distributing. I'm going to put that x cubed in front. 3x squared, these are gone. Oh, that's nice. Minus 3x squared times x cubed minus 1. Is that right? Is that what y'all got? And so then I have 3x to the 5th minus 3x to the 5th plus 3x squared over x 6. All that to come down to 3 over x to the 4th. So I don't know, it may have been easier to multiply. How did y'all do this one? Did you multiply it out first? Was it easier or the same? A lot easier? So it just depends. Anything else? I see these a lot that come up in multiple choice questions for some reason. Suppose u and v are functions of x that are differentiable at x equals 2, and u of 2 is 3, u prime of 2 is negative 4, v of 2, I told you calculus loves u's and v's, is 1, and v prime of 2 is 2. So we're going to focus on derivatives at a point here using our, they are very close. And if you look at your derivative sheet, there's a lot on here that use the u and v's, I think. It just is what it is. I don't know. First thing we want to do is, what is the derivative? And we're doing all these at 2. Of u times v. This is just the product rule. That's all they're wanting you to do here. Derivative of the first times the second plus the first times derivative of the second, right? What's the derivative of the first? At 2. Negative 4. Derivative of the second at 2. Y'all see where I'm getting this? Plus, what's u at 2? 3. What's the derivative of v at 2? It's that easy, y'all. Think it's easy? This is kind of like whenever we did function composition and everybody got composition, and then whenever we did composition at a point, everybody's like, Shane, what are you doing? It's just at a point. We're just plugging values in, so you should get an exact answer. What if I changed it to, you try this one. You try Yeah. Oh, I got so excited it was so easy. You can do B and C. Let's do B. Derivative of, you try this one on your own. I should probably say when x equals 2. Proper notation. Are y'all confused? Okay. Hmm. We'll plug one in. You got to find the derivative of that and then plug in. Yeah. All right, look, let's do, let me help you some. What's the derivative of 3u? 3 u prime, right? The 3 can come out front, but I still have to do the derivative of u. Are y'all with me? Does that make sense? I don't know. U is a function. I don't know what it is. If u was just a variable, if it was just x, I could just say the derivative is 3. But because it defines them as being functions here, I have to assume it could be something else. U could be 5x squared plus 7. I don't know. So I'm going to take the derivative of it here. What about the derivative of negative 2v? How about the derivative of 2uv? What'd you say? That's the equation thing. That's a product, so I need to use the product rule. I can put the two. You could, yeah. Smarty pants, Henry. Yes, you can do that. I know, yeah. Henry says that we know that u times v prime plus u prime v, or whichever order you do it in, is actually equal to 2 because we just did it in part A. That's what we did in part A, u times v, and we got 2. And now u prime at 2, negative 4, and v prime at 2 is 2. So I get negative 12 minus 4 plus 4, which is y'all good? That was easy. Okay, let's pick it up. This one's fun. Find the equation of the tan line, not the slope, but the whole equation, when x equals negative 1. Equation of tan line, when x equals negative 1. Mark, set, go. Derivative at that point. You don't even have to do h to 0 now because now you know a shortcut to doing derivative. Now, if you just want to do h to 0, you can. It's a lot of work, though. Until the end, that's right. So it looks like this is going to be a quotient rule for me. What do you mean? No. So that's only, you only do that when you do the derivative. So if I'm doing the derivative here, I'm going to do derivative of the top. So I will do that, which is just 4x cubed times the bottom. Remember, because it's derivative of the top times the bottom, minus, and now I'm going to do the bottom, the derivative of the bottom, times the top, x to the 4th plus 2. And everybody goes over the bottom squared. Yep. And at this point, you can plug in 1 if you wanted to, or -1, whatever it is. I'm going to go ahead and clean up a little bit here. Really no point. I don't have to go this far with the simplification process, because what I'm looking for, I'm just OCD. What I'm looking for is the slope at -1. So what I want is y prime of -1. So if I plug a -1 in here, I get 1 to the 4th minus 4 over -1 to the 3rd. I just plug -1 in because it asked me for the equation line at x equals -1. So I get 2 minus 4 over -1, which would just be I took an x out of everybody. Again, it's not necessary. If you want to leave it just like that, at the point, I could have plugged 1 in whenever I was here if I wanted to. Or -1, I'm sorry. Yeah. Yes, I'm fixing to. I was letting everybody catch up. All right, so understand what I've done here. This is the equation for the derivative of y. This is at -1. So that means the slope of the tan line when x equals -1 is 2. That's not enough to write the equation of a tan line, though. I need a point to go with my slope. So since I'm at -1, I'm going to go back to my original equation, and I'm going to find y of -1, right? That's the point of tangency that I'm looking for. So my original equation was, remember, x to the 4th plus 2 over x squared. So I'm going to plug a -1 in there. -1 to the 4th plus 2 over -1 squared, which would give me 3. Are we all okay there? So this point is -1, 3. So there's my point and there's my slope. So y tangent when x equals -1 is, actually, let me not write that yet. Let me put point slope form first. Y minus 3 equals slope times x plus 1, and now I can write it in my correct notation. I'd probably just leave it like that. If you want to distribute and clean it up in slope-intercept form, that's fine too. Khalil, you look really tired. Before I set you loose, 2 more things to show you. I don't even know that I really need to go over this. But what if you want to find a horizontal tangent? Number 12 says, find the values of x for which the curve has horizontal tangents. And here's of what? The zeros of what? Of the derivative. That's exactly right. So if I want to find the horizontal tangents, I need to find y prime and set it equal to 0. Well, gross, what's going to happen here? What's the derivative of that monster? Uh-huh. How are you going to find the zeros of that? Graph it? Well, what if this is a non-calculator problem? Take out an x, and you are exactly right, Alex. You're probably going to have to do, if it won't factor for you, and in this one it won't, you're talking about quadratic formula. So either quadratic formula or calculator is what I'm going to have to do there. This one is a calculator problem, but if it were not a calculator problem. But definitely, y'all remember how to use your calculators to solve and find zeros, right? If the equation equals 0, just calculate where it crosses the 0 every time. If it's a cubic, I probably have how many zeros? One of them, that's exactly right. One of them is 0. Should have 2 more here. You can do discriminant if you want to see if they're real or imaginary. That would be a quadratic formula if you were doing it algebraically without a calculator. If they're not going to give you a calculator, though, I guarantee you it's going to factor down for you. Just because they're real funny about timing and things like that and how long it's going to take you to do something. It does not ask you to find the whole point where it just says the values of x. The other ones should be at like, you're going to have to really zoom out on it. One's at negative 185 and the other's at like 15. No. You should still get the same answers. Oh, 0.198. I'm sorry. I wrote it. Point. I'm sorry. But it's still, it should be 0.198 and 5.052 should be your other 2 zeros besides 0. 3. Always 3 for AP. You will lose your answer point if you don't take it out 3 places. And that is stupid. More is fine, less is not. And you can always leave your answer on FRQs. If you could plug it into a scientific calculator, you can leave your answer like that. And it's okay. Yes. Just 5 squared. Yeah. Only whenever you have to round. You have to. I told you 2 more things. That was one of them. The other thing, and it's super duper easy. We don't just take first derivatives. We don't just take the derivative of a function. We take second, third, and fourth derivatives too. And we keep going. I know. We could write, let's see, first derivative looks like this, the second derivative, the third derivative, and so forth. I know, it sucks, y'all. In the other notation, if we start with y and we do dy dx, the second derivative would be d squared y dx squared. This is where it starts getting confusing in this notation. So this is first derivative, second, and you're just taking the derivative of the derivative. And this is going to be important a little bit later on, but let me just do one with you quickly, and I will shut up and be done. I promise. I keep saying that, but I haven't yet. We are working through your homework problems, though, so that's nice. Let's do the hardest one. 36 is the hardest. 36 gives us an equation. Does that sound like somebody barking? Did y'all hear that? Find the first 4 derivatives of the function. Pace Academy. Pace Academy. In Columbia City School. It's for kids with, like, learning issues. I think so. Y'all want to do the first one together? Let's do the first one together, and then we'll look at what we do. All right, so first derivative here, or dy dx, however you would like to notate it. I might, instead of doing quotient on this, I might do product rule instead and change this to this. It's not wrong if you do quotient by any stretch of the imagination, but I'm thinking if I'm doing 4 derivatives here, by the time I keep squaring that bottom and doing stuff, I'm going to end up in a lot of work. I think that I'll do this. And what I might even do is simplify this further to be, what's x to the negative 1 times x? X to the what? 0, which is 1 plus x to the negative 1. I think that's going to be a lot easier for me to work with and try to derive than what I started with. What do y'all think? It looks a lot better. So first derivative. What's the derivative of 1? 0, so that's no good. And then what's the derivative of x to the negative 1? Negative x. That was a lot better than the quotient or the product, right? How about the second derivative? Yep. How about third derivative? So? Well, it's negative 2 times negative 1. X to the what? How about the fourth derivative? Exactly right. Could you imagine if we'd done product or quotient all the way down 4 times? Holy cow. All right, what you think?